Alright, today we're going to discuss how to tell if data is normal. So what I've done is I've kind of preloaded some data here in Google, Geogebra. Let me just show you the opening screen in Geogebra so you know what I did. So I hit Geogebra, went to geogebra.org. There's the website. There's how you spell it and all that jazz. Then I went to start creating. And it's going to ask you for 6 choices. I'm going to pick spreadsheet since I'm entering data. I don't want to do that because it messes me up every time I do it. So I went ahead and did that. This is what it appeared as, kind of. And then I entered my data in A here, and there should be 36. There are. Okay, so there's 36 numbers there. This actually represents the carrying capacity of a refrigerator. They randomly selected 36 refrigerators and measured their actual capacity of what they could hold. And so I'm going to go ahead and then create a histogram. So what I did was I hit this button at the top, which is one variable analysis. And when you click on that, you get this graph on the right. You have to do that first. And so it's a histogram. And I'm going to change this so that we can see a few more divisions. Here we go, one or two more. That's probably too many. There we go. I like that one. And so here's our histogram. So to me, this looks fairly symmetric. So we're trying to decide if this data that we've collected is normal. This looks fairly normal. It looks fairly symmetric based on the histogram. There's a couple other things you can do. The next thing you can do to check for normalcy is to do a normal quintile plot, which or a normal probability plot, excuse me. So a normal quintile plot, or in Geogebra they call it normal quintile plot, and we'll click on that. And I'm not really going to get into what this means right now, just that you can do it and find it. Your graphing calculators can do this as well. It's probably called a normal probability plot in graphing calculators. But notice how all the points kind of line up here along this line. Okay, this is telling me that it is normal. When you have deviations from this, then it is not normal. A third way you can test for normality, is to actually find, so I'm going to go ahead and click this to bring up this SumX button, which brings me all my statistics. And notice my mean is 15.825 right here, and my standard deviation, which is S, is 1.2171. Now we use S because this is a sample. So this is the standard deviation of a sample. We wouldn't use sigma, this little symbol above it, because that's if you had population data. So we've got our mean and our standard deviation. So let's just check, does it follow the empirical rule? Empirical rule is when you have between -1 and +1 standard deviations, you have 68% of the data, 2 standard deviations is 95% of the data, and 3 standard deviations is 99.7% of the data. So if you're not sure just what that means, look it up so you can get a nice graphic of the picture. So anyway, if you do this, and we add 1.21 to 15.825, you get 17.042. And if you subtract 1.25 to 15.825, you get 14.68. Well, if you go back to our data and count them, 22 of the 36 are between 14.608 and 17.042. And so, you could just go back and go through it. So like 12.9. That falls outside. That doesn't work. 15.2, 16, both of those fit in. And so you can just keep going through and counting like that. And then notice 2 standard deviations, 34 of the 36, lay between 13.391 and 18.259. So 94% of the data. And if you go out to 3 standard deviations, we end up with 100% of the data. So that's another way. That one's a little bit more cumbersome. In my class, whoops, wrong one. In my class, if you do the interquartile if you do the the normal quintile plot or normal probability plot, and you look at the histogram, that's going to be enough to show that it is indeed normal. So let's look at another set of data that maybe isn't quite as nice. Let's see if I can find it here. I've got too many windows open. Okay, and I found it here. And now this time, we have quite a few more points here on this one. So we've got, I think 72. Yeah, there's 72 pieces of data. And here I haven't graphed it yet, so I'll just kind of show you my whole process. I just entered the data. This is, we injected rats with a live bacteria. This was how many days they stayed alive. You know, kind of a morbid way of looking at data, but that shows you, you know, we had a couple rats that really lived a long time, 511 days. So not some of them survived the injection. Some of them not so much, 43 days. So this just shows you some just general data. Who knows if it's even real? I just found it somewhere. So the next thing we do then is we go ahead and look at the histogram. So you click here at the top, add one variable analysis, and hit that button. And we'll come over and, oops, I didn't highlight the data. Should have highlighted the data, excuse me. So I'm just going to click on the A so all the data is highlighted. Now I'll click on it, one variable statistics. And we get this histogram here on the right. This is not normal. Definitely this is a skewed right histogram with probably some possible outliers. Looked like possibly 4 outliers. And we could probably find those with the box plot. Let's look at the box plot. Oh yeah, way more than 4 outliers. We got 1, 2, 3, 4, 5, 6 outliers according to the box plot. And then just to kind of show you what the normal quintile plot looks like, we'll click on it, and you can definitely see that it's trailing off, and this skewed right, you can really see that skewed right as these points fly to the right of that line. So this normal quintile plot can also show you skewness as well. But it definitely proves that in this case our sample is not normal. So we cannot use a normal distribution on this. So hopefully that helps you kind of get an overview of how we tell quickly how things are normal or not normal in this class. So best of luck, and I will see you next time.